Right, so I got caught up in the last video. That's okay. I also just realized that you can totally see me here. I didn't know that. Hey. So we are going to be talking about the library. So this is the third scenario and the last one. And we are going to plot a point that is 3 kilometers north and 4 kilometers west of our house. Okay, this is where our public library is. I'm going to make our public library a book. All right, great. It's a terrible book, but okay. So 3 kilometers north and 4 kilometers west. So we're going to start here. 1, 2, 3, 4. Okay, so that's where my library is going to be. Great. So I've just plotted that. 3 kilometers north, 4 kilometers west. Remember, we're using our compass rose to kind of help us out here. All right. It says if you had to walk to the public library from your house, what would the total distance be that you traveled? Okay, so I want you to think about, like, we have to kind of go around all these blocks to get to the library. So how many kilometers did we go? How many kilometers did we have to travel to get here? Okay. And then finally, this is where displacement gets a little different. It says if you had a flying car and could fly over all of the city blocks instead of walking around them. First of all, how awesome would that be? You could just like jump over everything. How far is the library from your house? This is the displacement. Well, this is a little different. So I think I have it here. How we figure this one out is by using something called the Pythagorean theorem. Okay, a squared plus b squared equals c squared. And I'll show you how we use that in just a moment. So if we look here, what we're trying to figure out is the distance was going up this and across this, right? That was our distance. But our displacement, I would like you to add this here. This is the distance and direction from start to end. And I like to call it as the crow flies, or like in a flying car, meaning like you go around all of those city blocks, you fly over everything, you cut the corners, okay? So I'm gonna just put like as the crow flies. That's kind of my expression that I use. Okay, so we're cutting corners, we're going over the city blocks instead of around the city blocks. Okay, so what displacement is that if I were to go from here to the library, but instead of walking around all these blocks, I'd go just like a crow flies, or like any bird that flies, and just go all the way on top and across. So I'm kind of cutting across here, cutting the corner. Okay, so what we've created here, folks, is a right triangle, not a white triangle. Like I said, it is white, but a right triangle, right? We've got 2 lines that go against each other. So how long is this end? This end right here. This end is 3 kilometers. This end, from here to here, is 4 kilometers. And I know that because if I start here, this is 0. And I go all the way across to here. And I mark it, come down here, and that's 4. It says -4, but we're just going to say 4 because it's 4 spaces, okay? So what you're going to do is you're going to plug that into your Pythagorean theorem. Okay, so these are the legs that we just found out. So this is 3, and this is 4. And you guys should all have this sheet. So we're going to set this up. A squared plus b squared equals c squared. You're just going to plug in the values that you found up here into a squared and b squared. It doesn't matter which order. So I'm going to do 4 squared plus 3 squared equals c squared. When we square a number, just as a reminder, that means 4 times 4. Okay, so 4 times 4, 16. When we square a number here, that's 3 times 3, right? So 3 times 3 is 9 equals c squared. So we're doing a little bit algebra. So we do 16 plus 9 in my calculator. And I get 25 equals c squared. Now we're not done yet because we've got this square here. So in order for us to get a square, we need to take the square root. If we take the square root of 25, we know that 5 times 5 equals 25. So 5 equals c. So what this means is that the distance is 3 here, and the distance is 4 here. But the displacement is just the distance and direction from start to finish. So if we start here, we go to here, we calculated it to be 5 kilometers. But because we're asking for displacement, it would be 5 kilometers in which direction? Which direction did we head to get to the library? Okay. All right, so we don't need this right down here. But up here, these are some things that we noticed. So in the direction, if the direction is the same, the distances can be added. So if we walked 5 meters east, stopped, and then walked 5 more meters east, that would give us 10 meters east. So which scenario can this be compared to? Would it be bringing groceries to Grandma? Would it be getting ice cream with Bobby? Or would it be going to the library? Pick one. Which one does this scenario relate to the most? Adding 2 distances together. I'm going to go in the same direction. If a direction, oops, I went too high here. If a direction is directly opposite, the distances can be subtracted. So you can walk 10 meters east and then walk 5 meters west. So 10 meters east minus 5 meters west equals 5 meters east. So think about the scenarios we talked about. Does that relate to bringing groceries to Grandma, getting ice cream with Bobby, going to the library? Pick one. Okay, so if the displacements are not in the same direction or directly opposite, they cannot be directly subtracted or added. You walk 4 meters east and then 3 meters north. 4 meters east plus 3 meters north, we don't know what that really equals, okay? Not yet. So we need to look at this figure to help us out. I'll give you a hint. For this one, we have to use something called the Pythagorean theorem. A squared plus b squared equals c squared. So which one of these scenarios does it most relate to? Is it bringing groceries to Grandma, getting ice cream, going to the library?